Let us take a look at the next topic within this lesson, and that is the topic of independence. Now here we are looking at a data set of people, and two of the columns, this data set is called bird keeping, and two of the columns are age and whether a person is a bird keeper or not. Okay, so we want to find out whether these two variables are independent of each other or whether they are dependent on each other. Okay, so if you look at the distribution of age of people who are bird keepers and people who are not bird keepers, okay, there doesn't seem to be much of a difference between these two distributions. Okay, notice also that this has been annotated with a model, and basically what this is saying is the average age of people who are bird keepers is in this range, and the average age of people who are not bird keepers is in this range, and we see that these two ranges intersect. Okay, so you can draw a horizontal line that goes through both of these models. Okay, which means that really whether a person is a bird keeper or not doesn't say anything about the age, and vice versa. Okay, so we can't say something like, well, people who are older are more likely to be bird keepers. You cannot make such a statement, even though this bar happens to stand slightly above this bar. Okay, very slightly above the bar. The top of this bar is kind of falling a little below this bar. Nevertheless, you can't say that people who are bird keepers are likely to be older than people who are not bird keepers, because the two bars overlap with each other. In other words, if you conducted this same experiment with many different samples of people, okay, you will not find that this is consistently higher than this. Sometimes this may be higher, sometimes this may be higher. Okay, so therefore you can't really say that this is explaining this. In other words, whether a person is a bird keeper or not has no way of explaining the variability in age. Okay, that's what we are seeing. That is mainly because the bands overlap. Okay, so independence, that means we are saying these two variables are independent of each other. They vary independently. The variance of one, the variation in one doesn't have any connection with the variation in the other, or as we have seen in the past, one doesn't explain the other, right? Whether a person is a bird keeper or not doesn't explain their age, and vice versa. Okay, so that is with respect to a quantitative variable along with a categorical variable. Here we are looking at two quantitative variables. Okay, so in this case we have annotated with a model, but the band is almost horizontal. Okay, what that means is that as this x variable increases, there is no real pattern in the y variable. It's not increasing or decreasing in any discernible way. And as we have discussed before, look at these points. The points are just all over the place. There's absolutely no pattern. Okay. Another way to say this is that if you repeat this experiment many times, okay, any horizontal line will fit into this band. Okay, if a horizontal line fits into the band, okay, that means that there is no real pattern between these two. Okay, that as this increases, there is no real discernible effect on this. Another way of saying it is that these two variables are independent of each other. One doesn't explain the other. Okay, that's the idea of independence of variables, right? So in the case of a numerical variable with in the case of a numerical variable plotted against a categorical variable, if the two model bands for the different levels of the categories, if they overlap, then you say they are independent. In the case of two quantitative variables, if a horizontal line will fit in the band, then we say the two are independent.